All right, good afternoon. Oh, come on, guys. I know we're in the Bellagio. I know it's late. It's only day one. How we doing? All right. For those of you way at the back, that is a bold choice, but we'll work with it. Who's here to build the next connected toaster? I just want the show of hands. We need to talk. We got VC funding for that a little bit later. Awesome. Okay, so my name is Mark. I run global business development for IoT at AWS. It's my pleasure to welcome you to IoT306 this afternoon. We're going to talk a lot about building IoT applications for the smart home, and I'm joined by two people who are really going to provide all of the insight. I'm just your moderator for this afternoon, so don't worry. We're going to stay level 300 session. It's fine. I'll be off in a second. But we have Jan and Barak who are going to come up and give both some technical detail and some great customer examples as we go through the presentation. And why are we here? I'm not going to go into it a ton, but home automation, consumer connected devices, still a massive, important market. One thing, I spent a lot of time with a lot of customers, some of our best consumer device customers, and the thing that always sort of is impressed upon me is when you do anything at scale, and with consumer devices, you get to scale very quickly. Things get very difficult very fast. Any IoT demo works with one device, and you start shipping millions of devices. Different technical challenges, different business challenges present themselves. It's also here we are on Cyber Monday in the U.S. I'm sure there's a few of these devices getting sold around North America and other parts of the world. A lot of consumer interest and a lot of consumer expectation as well. And the market, for all of the opportunity, there's a lot of challenge. And when we spend a lot of time with customers, these are the sorts of things that are top of mind. I mean, first and foremost is how do you really differentiate a product? A thing connected simply for the sake of it, that might not impress your customer as well as you would like. How do we drive a level of innovation and really feed that customer expectation? It's hard to improve upon devices and keep costs low. The margins on these devices can be razor thin, and so you want to be able to have devices that evolve in a connected world. I think that's a bit of a customer expectation. Things like thinking about interoperability between devices, thinking about having the required security and scale of the underlying platform, and thinking about how the edge, in addition to the cloud, can really drive a level of innovation in these devices are all really the top of mind things for the customers that we've been working with. And so what we thought we'd do today is explore three sort of big areas in the smart home. First being home automation, second, home security, and the third being home networking. And what we're going to do is really explore some examples of what people are doing, some examples of how we think the various AWS IoT services can help make it easier to build, take out some of the heavy lifting in building these applications, give you some ideas and a little bit of depth. We're going to go through some fantastic demos. But we're also going to hear from Barak as a customer, both on what they've done technically, but also the business challenges that they've faced. At a super high level, this is what we're talking about. The devices in the home, how it leverages our edge technologies like FreeRTOS embedded in a device, how a gateway or other controller device powered by Greengrass combined with more powerful devices like cameras can build new connected home experiences. How you leverage the cloud and really a core set of services, AWS IoT Core, device management, device defender, and analytics to help you build not only the underlying infrastructure, but value-added applications and connect to the rest of AWS for things like database and compute, machine learning, and other capabilities across the various products from AWS. And then how does that translate into end applications that your customer is going to be using? And we'll touch a little bit. We're not going to spend a ton on voice. There are a bunch of dedicated sessions, but we're going to sort of feed those sessions with here's some of the plumbing that you need to have in place to have a fantastic voice experience. We'll touch on device onboarding and a few other great demos as we go through. But to kick it off, let's go into that first area in home automation. And we sort of see four really big areas. Voice is huge for our customers. I think there's a customer expectation of both voice control and sometimes embedded voice capability into a device. There's sort of command and control capabilities and interoperability between devices, typically driven by some sort of hub, finding new kinds of customer experiences, and then, probably most importantly, how do we make this so it's super easy for the customer to take advantage of? I'll give you some theoretical examples, and these are places where our customers are using the technologies today. Let's take a smart TV as an example. We have several customers using AWS IoT Core as the main communication channel between a smart TV and their cloud infrastructure and applications. That might include things like AV control and voice, similar capabilities. Amazon FreeRTOS, for those who aren't familiar, our embedded operating system, Amazon FreeRTOS comes with all the hooks to get an embedded device up and running with AWS really easily and quickly. And so you think about all those smart bulbs and LED devices and other embedded systems that require that embedded development. That's where FreeRTOS comes into, Amazon FreeRTOS comes into play. And then AWS IoT Greengrass brings a little piece of AWS to your devices. So Greengrass brings essentially our IoT stack, our machine learning stack, our capabilities of Lambda to hardware, particularly gateways and other kinds of hub devices in the home. So those are the sorts of things that we're talking about. But enough of me. We thought we'd kick out. We're going to get to some hardcore demos, but we thought we'd sort of kick this off with the voice of the customer, being as customer obsessed as we are. And so I want to invite Barak from Vestel to come up, talk a little bit about who they are. You may not know who they are, the kinds of things that they're building and how they're delighting their customers in the smart home world. So big round of applause for Barak. There you are, sir.
Thanks. Thanks, Mark. Hi, everybody. My name is Barak Savak. I work for Vestel as the VP of IoT, Cloud and Automation. Me and my organization are responsible to put everything together in Vestel among all the devices that we are manufacturing and create an ecosystem that all those works in a harmony alongside, inside with them, as well as the third-party services. To put things into perspective, I would like to talk a little bit about our organization. We are the part of the Zorlu Holding, which is established as a textile company in the 50s. Since then, it's kept growing up and currently operating in more than 8 major industries, from energy to mining, electronics, yada, yada. And it is currently being one of the top 10 holdings in Turkey, with more than $7 billion turnover and more than 26,000 employees. Vestel is being the admiralship of the group, and it is acquired by Holding in the early 90s. And it is started as a TV manufacturer, like an OEM. And since then, similar to Zorlu Holding, Vestel also kept growing up, become an ODM. Now we have our own brands that we are managing in Europe and EMEA region, like Toshiba, Hitachi, Telefunken, and so on. We are manufacturing more than 500 brands, and we have the capacity of manufacturing 35 million devices every year, and currently manufacturing 25 million. Since the TV business started, also Vestel kept growing on the different devices, and currently we are manufacturing more than 20 major consumer electronic devices, from the cell phones, white goods, visual solutions, LED lighting, etc. And we are third in the TV sales in Europe and fifth in the white goods sales. And we are the largest manufacturing facility in Europe, with more than 1.1 million square meter closed area. So I would like to continue with something that we have done Vestel quite a few times since the beginning of the company. I really like the quote from Jeff Bezos very much because it is stressing the importance of the keeping up with the change. That is the probably most crucial thing for the survival of the company and keep growing and keep surviving and living. We have done this in Vestel several times, and these times also probably the fastest pace changing ever in our lives in the electronics industry. Everything's changing. If you take a washer, for example, it was for decades, it was a device that is sitting on the corner as a standalone device. And now it become a connected device. The face of everything, the usage of all those devices are being redefined. And to do so, we have a big job in Vestel because, as I just mentioned, we are manufacturing from white goods to brown goods, automotive, smart home devices, lighting, mobile, etc. Beside the business needs, like the elasticity of the services, cost is very important, as Mark mentioned, because these devices are very low margin devices. You need to be very cost aggressive and aware. And also flexibility of the system that can connect to the other third-party services. Because the world of the IoT is going to be heterogeneous. It's not going to be homogeneous, one place that you will connect and everything will be dandy. It will be very, very heterogeneous environment. Therefore, your ecosystem should be able to adapt other ecosystems and enroll to the other ecosystems as well. So, where we have started was a very basic cloud system. As you could see from here, our white goods were going to some EC2 machines on the Amazon, AWS, and our TVs were going to do some other cloud. And those two clouds were completely separated from each other, not talking. However, the company well understood the necessity of the setting up a nice and sound environment and ecosystem that will work in harmony. And then our group is established. About 2 years ago, our group is established, and that is the time that we have started some talks with the Amazon folks. Thanks to them, we had very many workshops together, and we put our requirements on the table, and they come to us, and we sit down and come up with a very flexible and nice architecture for our cloud. Because, as I said, we had two different needs. One need is from the business side, razor-thin margins, flexibility, elasticity, interoperability, etc. On the other side, the customers. The customers would like to invest on IoT stuff, but when they are investing, the most hesitant part of them is the device that they are investing in, paying extra, is it going to work in a couple years' time? Is it still be up to date, and is it still going to get new features available? Or is it going to become obsolete and not usable? So on top of that, usability. It should be usable. It doesn't matter if you have the best technology in the world if the device is not usable. So those requirements in mind, we come up with a nice cloud architecture. I should also mention that we had legacy devices in the field from the two previous slides that I showed. We needed to keep them on the board as well. We couldn't leave them on behind. So with the Amazon team, we come up this architecture. On the left side of the slide, you see that our legacy stuff with the necessary elasticity added, with the load balancing, etc. And we still keep them in the field, and we still can give some new features to them. But we set up our own main cloud, our future cloud, on top of the Amazon Web Services. Because in the legacy, we weren't utilizing the standard services like the device management or software update or security kind of stuff was all done by Vestel stuff. And that wasn't very feasible because in that time you end up creating your own cloud. However, while you have these services available from the Amazon Web Services, why do you implement them again? And they are already proven, sound, working in the field on many million devices. Rather than focusing on that kind of services, we just gathered them from Amazon and we focused on the add value and the differentiation on our side, rather than doing the already done. So for that one, we started to utilize the IoT core and FreeRTOS on our white goods devices because they were very small footprint. We needed an operating system that it should satisfy security and device management and the device updates, which FreeRTOS and the IoT client gives that. And also on the integration of the third-party services, we went with the API gateway. By using the API gateway, we didn't need to implement the skills for our devices over and over again for every third party. Rather than that, we are writing plugins, and by this way, we can integrate with the Google Home or Amazon Alexa very easily. And the same skill is being used. And when we do an update, it goes to both. And by doing so also, we don't need to do software updates on our devices. We can enable third-party services very easily. However, this is not the final destination that we would like to reach out. We would like to go to a fully serverless ecosystem. By this way, we will do away with all the EC2 machines and carry them over to all Lambda functions and the serverless architecture as the next step. That's what we are working right now. And also adding the data analytics to create better devices and analyze our customers better and to be able to create other services and share to be able to use the data for these purposes. By creating this cloud, we are satisfying all the needs that I mentioned in the in my presentation. From the business point of view, price-wise, very affordable and elastic and also scalable and very easy to integrate with the other third-party services. And for the customers, usability, new services, and future-proofness is accomplished. And as I said, thanks to Amazon team achieving this, they helped us to find the right architecture and implement the right architecture. And hopefully this would help some of you guys in your future digitization journey. And thank you for listening to me. Mark? Oh, Jan.
So hello, I'm Jan Borch. I'm an IT prototype architect, and I will go through a little more some technical details about my experience building home automation system with my customers. So the first thing I want to say, so thank you, Burak, for this very fascinating kind of IoT at scale use case. And in this context, what I want to emphasize is that for your home, if you're building a home automation solution, one of the key aspects is that the unboxing and onboarding experience of your end user needs to be as simple as possible, but still secure. Achieving this is key for adoption of your devices. So I will go a little bit into technical details and best practices around onboarding and unboxing of your IoT device and how our platform can help you in those things. So if we summarize, what do you need to do? What does the customer needs to do when it unboxes the device, your home automation device? The first thing is, of course, a lot of home automation system needs have a mobile companion app to control, to monitor, to configure the devices. So they need to install this app and create a profile. Then you have to set up device connectivity. When we're talking about Wi-Fi enabled devices, they need to somehow connect to your Wi-Fi router. Then there's a backend thing. So the new board devices needs to be assigned to your user profile in the backend cloud so that you can verify ownership. And at the end is also when this device communicates over MQTT, for example, with Avs IoT, it needs also to be registered on the Avs IoT side. So now these are all mandatory steps to get a connected device up to the cloud so that we can communicate back and forth. But can we simplify this? That's the whole question. That's a lot of steps a customer has to go through. And you can. So I will show you here now some best practices about how to do this. So first, where can we help on the mobile device companion app? Amazon Web Services has a lot, AWS has a lot of services that can help you building a very compelling mobile app. Of course, we have Avs IoT SDKs for Android and iPhone and iOS that you can use to build into your apps to communicate with our AWS IoT platform. We have another service called Avs Amplify. It's an open source framework that is very useful to build like scalable, reliable, and secure serverless backend services for your mobile app. One of the great things of Avs Amplify is that with one click, with one command, you can, for example, add different features. One of the features that's quite interesting is the authentication module. This will give you a skeleton app with a fully featured authentication end user experience. Backed by Amazon Cognito and Amazon Cognito user pool, and you can even integrate with other identity provider very easily by just specifying this one. Really dramatically improves and speeds up the development of mobile apps from an authentication perspective. So, second, we need to get some credentials on the device. Why? Because AWS IoT mandates TLS 1.2 with client-side authentication. So we need key material on the device. How do we get that? There are two ways. Often, it's the mobile app. The end user is connected on your mobile and authenticated. So it can connect to the Avs IoT, generate key material, download them, and push them to the device, for example, over BLE or by putting the device into an access point. But again, that's another step the customer has to go through. It's kind of cumbersome on that side. There's other recommended way. What you can do is at manufacturing time or just before the device goes out to the customer, provision the keys on the device. We call this just-in-time provisioning. So you register your CA, your certificate authority certificates on our platform. You sign your keys, you create key material, you sign it with your CA, you put it on the device. And when the device first connects, we will provision the device on our side and enable connectivity if the CA is authorized to do it. So a great way to simplify also this process. So the next one is, we are talking about connected devices, so they need to connect to the internet somehow. Most of the time, the device is over Wi-Fi connects to your home router. Again, if at the moment you need to somehow get your SSID and your shared key to the device, to the mobile app or other means. If you're currently designing a home automation solution, I would strongly recommend taking a look at the new WPA3 specification. First devices will hit the market in 2019. In the WPA3 specification of the Wi-Fi Alliance, there is a new device provisioning protocol. Where a mobile app, the companion app, can, by scanning, for example, a barcode with to get the public key of the device, can configure the router to allow connectivity of the device with things without having to kind of key an SSID or Wi-Fi password on the device. So the onboarding provision is just done by scanning a barcode on your device box, and the router will automatically be configured so that to allow access of the device. If you're currently designing, I would highly recommend taking a look. This also simplifies the Wi-Fi onboarding. The next step is the pairing devices with user profile. What do I mean with this one? So of course, when the device is bought by a customer, you don't know it. So when he first connects, you have to somehow make the relationship between the device and the user profile in your cloud backend. So again, most of the time, this is done by scanning a barcode or by entering a serial number that you can find on the box or on the devices in your mobile app. Now, I just told you about this new way of connecting Wi-Fi with scanning a QR code. So you can combine these two steps into one. You scan the barcode. In this barcode, you would have, of course, the public key for the Wi-Fi configuration using WPA3 Easy Connect. But you could also have a serial number of the device that can help you, in fact, establishing a relationship between this device and the actual user connected on your device. And then the last steps is, once we have done this one, the device first connects to Avs IoT, can start exchanging message, sending telemetry data, getting command from the cloud. So here, as I said, just-in-time provisioning really helps you. At the first connection, Avs IoT will intercept, will verify the CA. If the CA is registered with our platform, it will provision the thing. This is in our device management. It will provision the certificates, and it will also provision a policy that allows certain access. Everything is defined in a template on our side. So in the next, after this one, I will show you in live in my next demo how this can be done. So just to summarize a bit, so what is important? What have we done? Instead, we had 4 different steps we had to do. So with this combination and with these best practices, in fact, we reduced this to 2 steps. Installing the mobile app, connecting with whatever you want, so we can also use an external identity provider like Google, Amazon, or any OpenID connected things, because Cognitus also allows this one. We create our profile, and then we scan the barcode, and all the other provisioning, the Wi-Fi connectivity provisioning, the user pairing, device pairing, and also the connectivity to Avs IoT is done automatically. So we have really simplified the onboarding experience, and it's really key, in fact, for adoption of your products. Good. So that was a bit some best practice around this one. We will now dive into the next topic, home security and monitoring, and Mark will introduce this topic for me.
Okay. So far we're building you still with me on the connected toaster? Are we still good? All right. Here we go. So we got a great idea. We found somebody awesome to help you build it. We've got this great unboxing experience. We're well on our way. Let's go into a few other parts of that connected home. So home security and monitoring is a pretty significant market. You see it both from interest from consumers, but also a lot of insurance companies and other security companies, some of the mobile operators who are providing these kinds of services. So you want to think about things like how can you more easily do audio and image recognition, level of machine learning around security, really great home surveillance applications. We put energy management into that category as well. So similar kind of concept here of some of the moving parts of our platform. We have Greengrass as a gateway device controlling a number of different devices. We have the IoT Core device management, Defender, and analytics helping build applications around it. And again, FreeRTOS actually powering devices. Amazon FreeRTOS is interesting because in most homes, because you have that hook from FreeRTOS straight to AWS IoT, a lot of the new chipsets, you have Wi-Fi chips directly in the locks, or it could be Zigbee or other standards. But those devices are becoming smart enough that they don't even necessarily have to go through a hub device to communicate with AWS IoT if you don't want. And then something that's developers are really beginning to dig into is using the machine learning inference side of Greengrass to help with the modeling for things like image and sound recognition, which is the demo I think we're going to see next. So we're going to get into some deeper code here. So let me hand it back to Jan, and we're going to do a little bit of an example of how you can build an edge application around home security. So let me hand it back to you. So for this demo, I took a very simple kind of use case in home security. There on the left side, you have a smart microphone, a connected microphone. Imagine that's a device, a small Linux device with a microphone that can record the ambient sound
and can process it for classification purposes. So it might be able to detect dog barking, a car siren, whatever, a cry, whatever you want that is security related. The other device we will talk about is a camera. So if we have a certain category of sound that has been detected, we might want to activate a camera for this purpose, these wings. Who will coordinate, in fact, these home automation devices is, for example, a security gateway, one in Greengrass, where these two devices will connect and exchange messages. On this abstract, we will also talk about machine learning. So how do I classify these audio sounds? I will show you how I'm doing this. It's using a machine learning model that will run on the device and at the edge for detecting these devices. So for here, I'm using SageMaker for the modeling. Of course, we have Avs IoT Core in the backend for capturing all the events. And then we can, of course, have a user interface for visualizing these things. So that's the small demo I want to show today. So let me switch to my screen. So let's start with the Avs IoT Management Console. So for the moment, we have two things. We have the camera, I already provisioned it, but you see that the connected microphone is not there yet. So the first thing we want to do is, and I want to show just-in-time provisioning here. I don't have physical devices here. I will simulate these devices running on my laptop. So I will use the microphone on my laptop and also things. So on the left side, you have the device 1. So the first thing to do is, in fact, I told you that we need key material. And I will show you just-in-time provisioning in live. So if I go to my cert folder, I created a small script, connected mic. So this generates, in fact, just a private key, a public key, and signs it with a CA certificate. You will see here that I have the connected cam, and here I have the connected key and that I need to do. Now, the other thing I will do now, I have a small test script that just uses Mosquito to connect to Avs IoT. You mentioned before you saw that the thing wasn't provisioned. So if I run my testing, this will launch an MQTT client connect to Avs IoT. You will see that at the beginning it didn't work, and then now it's publishing things. So this is live just-in-time provisioning in action. When I switch back to my management console, you will now notice that I have the connected mic thing that is there with the certificate, with the rights to access, and with the right to connect. So that's how you would kind of provision your things with just-in-time provisioning. Okay, now let's start my thing. So I wrote a small Python script that simulates a smart microphone that will listen to my microphone of my laptop, will process the audio with a machine learning model called WGGish, if you want. If you're interested in looking at what it thinks, this is it's a research project from Google, and it was trained on 30 million different kind of audio files. So if you're interested, okay. So let me start. So I already have the sound. That's annoying. So it will take some time to boot up. It will load the different model. It will connect to my microphone, and it will start processing the audio stream. So this is a simple audio stream you see here. Every second it reads, and after 10 seconds it will process it to the machine learning model and extract an embedding. An embedding is a fingerprint of the audio wave of 10 seconds that we will use later on for classification. So that's my model. You also notice that at the moment it's connected to Avs IoT. So we can go to Avs IoT and see how it looks like. So if I go to my test model, I subscribe to the topic. You see, that's the kind of embedding things. So these are 128 bytes per second. So I'm transforming my 80 kilobyte per second audio stream in 120 bytes. And these bytes represent the high-level characteristic of my audio file. And these can be used as kind of a fingerprint, can be used later on to classify and to recognize different sound patterns. Now, how do I classify? How can I now find out that this is a dog barking or this is a car siren? So in this one, I used a training set called audio set, which is a training data that you can use for creating your machine learning models for sound classification. So I used SageMaker, and this is a SageMaker notebook, if you're not familiar. But in a nutshell, what I'm doing is I'm loading my training data here. I'm creating a very, very simple MXNet model with 3 layers. This is my training function, and if I execute my training function, you will realize that it starts training. Now, the model is very, very simple. Normally, if you want to train it on the full data set of 2.5 gigabyte of data, it will take like 2 hours to train. So my model is not very accurate, but it serves the purpose of the demo. And then it serializes it and then things. Now, this is how you evaluate and how you test your machine learning model we want to put on the edge. Now, if your data set is bigger, or if your model is more complex, SageMaker also allows you to run this model on an EC2 instances, for example, with a built-in GPU, which will highly accelerate, in fact, the training and things. So how does it look like in SageMaker? This is very important, because if we go to our training job, we just see that's the one I just launched. It will launch on an M5 instance. We'll train, we'll download the data, train the job, and save it. But what is the result? So I don't go into all the detail. The most important part is, it's this part. So what does this training job made? It created the machine learning model, serialized it, and puts it on an S3 bucket for downloading. Now your inference function, the function that will execute, get the input event and classify it, just needs to download the model and execute it. So let's do it. I created a small Lambda function for doing this classification. We just have to connect it. I showed you here that we have the events coming in from my smart microphone app into the IoT. We just have to connect it to our. So in Avs IoT, we have this concept of a rule. So I will create a classifier. So I select all the events from my connected mic. And I will execute my pre-built Lambda function. That's the audio inference one, which would use the model we just trained in SageMaker. Great. Okay. I have to do it again. So, okay. Select all my payloads from the connected mic. And I want to execute my Lambda function. So again, now you know how it works. Good. So this Lambda function will be executed with these embeddings I just showed you and will return a classification. So my model is very simple. I just had 2 sounds classification. I can detect dog barking and I can detect a police car siren. If we go back to our test client here and look at what it's. So every 10 seconds, it will classify. OK, now, my model is a little bit stupid because it dog barking when I'm talking, it thinks it's a dog. But OK, that's how it works. What I can of course do is I don't know if you will hear it, but I recorded a police car on my laptop. And let's see if my very sophisticated machine learning model can detect again the dog barking. Car sirene, wow. Okay, so that's the first step. Now, of course, here I'm classifying it in the cloud. But what we want to do is we want to classify this on the edge. Why? Because if there's a security-related event, we want even, and for example, your home network is down, you want to be able still to detect these things. So let's move this Lambda function I've created in the cloud onto Greengrass and run it, for example, on my gateway. So if I go to Greengrass here, I already created a Greengrass group, and I have installed Greengrass on a server, on an EC2 instance for the moment. What I will do now is take this Lambda function and run it on the EC2 instance. So the first thing we need to do is define the Lambda function. So again, we take the audio inference Lambda that we just run in the cloud, the last version, and we reference it in our Greengrass group. Just need to configure it because we need a little bit more memory. We need 100 megabyte, and we need a little bit of timeout. No, that's the wrong one. X. So lambdas, that's the audio inference. Yep. So I was clicking on the wrong. So we need 100 megabyte. We need 30 seconds, and I just need to tell them where SageMaker will download the model. That's fine. That's all we need. The other thing we need to do is now we want the model I trained in SageMaker. We want to push it also to the edge. We might have different models that we want to push. So in Greengrass, we have these capabilities of resources where we can reference a Greengrass model that will be pushed to the edge on our Greengrass machine for execution. So we call it model. I say I want to use a SageMaker things. Here you see the same model that we just trained in SageMaker. I will take the one from the 22nd of November. Here I just need to put the same model, and I need to explain where this model or these files will be mounted, and we are good. So we have now a Lambda function. We have now our machine learning model. The last thing we need to do is in Greengrass, you have this concept of subscription that explains how the data goes from one to the other. We have our mic, connected mic application that pushes events to Greengrass. So what we need to do is add our mic to Greengrass, so that instead of connecting to the cloud, we will connect to Greengrass. To do this, we need to define and reference the mic on our Greengrass group. So that's the one. And the last thing we need to do is call the subscription. So we want the data that comes from our device, from the connected mic. We want to push it to the local Lambda function, the audio inference one. That's all we need. So that when there's embedding coming on over the event, we call the Lambda function. And the other thing we want to do for debugging for the moment is that the outcome of my local Lambda function, I want to send it to the cloud so that we can look in the cloud how it. So we're all set. This is all the steps you need to push a machine learning model and Lambda to the edge and run it on for example, your security gateway. The only thing we need to do is we need to deploy it. So all this configuration will be pushed now to my Greengrass that could run, for example, on your security gateway. You just need a Linux box with 128 megabytes of RAM and a 1 gigahertz core. So it's pending, successful, completed. What we should see now in the cloud is the same classification model, but now coming from. So if we audio. You see that the topic is now audio Greengrass. So the classification model that runs in the cloud, now I pushed it to Greengrass on the edge. It's executed on the edge. And interestingly, if I looked at my simulator, you may notice at the top here that now it's not connected to Greengrass anymore. It discovered that it was added to a Greengrass core. It got the connection information from Avs IoT. It switched connection and connected to the local Greengrass in things. So this is called Greengrass discovery. So a Greengrass device can discover if there is a Greengrass inside the network that is reachable. And it continues doing this one. Okay, so that's a bit the model I wanted to show on this device. Good. So let's go to the next section.
Okay. I guess we got to.
Okay.
Are we switched back? No.
Oh yeah, it's this one.
That one. Perfect.
Go one. We can skip this one. Yeah. Go to
So
home networking. Yeah.
what's super interesting about that demo, one is the sales guy. I learn something every time I hang out with Jan. But when you think of Greengrass as this sort of universal targetable runtime, and you're using the same tool chain from the cloud as you are out on the edge, that's pretty compelling, either just from a developer training perspective and a deployment model perspective that a number of our customers are investigating how they can think of new and more advanced applications. So the last one we're going to talk about is home networking, and I'll go pretty fast. Here's the big thing about home networking, which is it is all about customer experience, right? The #1 support call that everyone gets is, come on, you're with me. My Wi-Fi is not working, correct. And the answer to my Wi-Fi is not working from customer support is reboot the router, right. So, and if that doesn't work, you're rolling a truck. As soon as you roll a truck, the economics of whatever it is that you've done have been basically ruined. You are in razor sharp margins again. So one of the things that we've been doing in the home networking space is thinking about how Greengrass can be used as, again, as a device hub, and deploying models that help diagnose networking issues and resolve those networking issues without having to have a call. We're also using device management, the new device management service for over-the-air firmware updates and deployments, and then using AWS IoT analytics for analysis of health of those devices. This is pretty compelling if you can be saving, if you're saving $10 a call across all of your customers, the economics start to work out. So for our final, and probably relatively quick, demo, back to Jan.
Yeah. So in this context, I wanted to use a service called Avs Device Defender, which is quite interesting. Device Defender allows you to kind of audit your devices and your fleet of devices. It can identify anomalies. It can monitor device behaviors, and I will show how this works. And it also can audit device configuration. So we have a bunch of pre-built kind of audit capabilities based on our best practices that you can run on your fleet of devices. Now, of course, to do this on the cloud, you need to capture metrics from the edge. And in fact, I introduced Greengrass in my previous example, and you noticed, I will show you, I will switch to my network here. Let me see. Yeah, and you noticed in my previous demo that there was the Lambda function called Greengrass Defender Agent. So this is a Lambda function that's running on the Greengrass device and is capturing information about the device. So capture information about the interfaces, the listening ports, how many established connections we have, and also statistics about the number of bytes and received and things. So all information that could be interesting to detect maybe devices that are behaving abnormally. So if I go, I will just show you, in fact, the how these messages look like. Oops. Let me see where. Okay. Oops. Let me put it a little bit big. So this is the kind of devices that our device defender agents sends from our Greengrass devices to our cloud. So you have information about ports that are used, interfaces, open connection on UDP and TCP, established connections, and so forth, and of course statistic about the bytes in, bytes out, packets in, packets out. Okay, quite interesting to have on the cloud. So what can you do with this information when you get it? Things. So in the Avs IoT console, we have things to defend. This is the kind of device defender capabilities. There's some generic auditing capabilities here that I won't go into details, but there you see kind of, okay, there are 2 out of 10 compliance settings that have been run that are out of scope, and then you can go into the details. There are shared device, policy that overly permission. So these are the best practices we built into Device Defender that you can run over your fleet of devices. More interesting is the detect features. So here, I created a security profile, a large amount of messages that detects devices that are abnormally sending messages things. Of course, if we go into the details, I put it up, of course, into a range. So the behavior you describe is not the behavior that you don't want to have, it's the behavior of a normal device. So what I told you is that on the receiving and sending, a normal device should receive less than 10 messages in 5 minutes. Of course, I make it deliberately so that it fails. So when you enable this behavior and you run these behaviors, you will see that you get violations. So this is the kind of 3 alarms. And the top violation, in fact, based on my previous demo, because my script was sending every 10 seconds an event, it's more than 10 per 5 minutes. So it triggered a behavioral problem and said, like, okay, we had 30 messages instead of 10, so this seems to be abnormal behavior. So by using this tooling on your home networking gear, by collecting these network-related devices, you can in the cloud detect anomalies on a large fleet of devices on your things. Okay? So that's a bit the small kind of device defender demo that was related to network security. Let's switch then back to PC. Oops.
Okay.
So conclusion.
Now, it's interesting, like, as I've been listening to you, living the dream of home automation. I think I've now received 15 notifications from my cameras and doorbells and motion sensors at home.
Okay.
So this must be a thing.
Yeah.
Otherwise, I'm a focus group of 1. So hopefully, this, so we've sort of painted a picture now. AWS IoT, the set of services, core, device management, device defender, the AWS IoT analytics, Amazon FreeRTOS, and AWS IoT Greengrass are all members of that AWS IoT family. Some great examples of what we're doing in home automation, security, and networking. Great example from a customer, and we have many others. If you want to learn a little bit more, there's a repeat of this session and then another breakout which goes into depth on the voice side, which is how Vizio is using Alexa and AWS IoT for the connected voice experience. It's sort of a parallel track to this one. And then there's a whole number of other workshops throughout the week. Thanks so much, Barak, for coming up and sharing. Thanks to all of you for making the trek over the Bellagio today to listen. Hopefully, you learned a little something about how to leverage AWS IoT, and thanks for Jan for some awesome demos. We have 5 minutes if there are any questions. There's a mic up here, and if not, thanks everybody for taking the time. Oh, there he is.
Oh.
Hello. Oh, God. When you mentioned the Greengrass auto discovery, were there any security implications around spoofing or things like that with that auto discovery process? How do you guys secure that with Greengrass?
Yeah, so I talked about this concept of a Greengrass device, for example, the connected mic. Of course, the connected mic has also a private and secret key and connects securely to Avs IoT using this key material. So it can identify at the platform with this key material. And that's also how Avs IoT knows that if somebody connects that doesn't have a right certificate, that is not registered in the device manager, it will not allow the discovery. So that's the thing. And also, once it's discovered, even if the device knows the endpoint, if it tries to connect to Greengrass, but in the Greengrass group the device is not registered, it won't be able to connect. So that's the whole security story. So it's the same security story on the cloud. We replicate it to Avs Greengrass.
Are those keys rotatable through the secret management system in Amazon? Or I should say, do Greengrass IoT devices have compatibility with like KMS or other such key rotation services in AWS?
So there are multiple ways. You can even bring your own keys. We don't, so you can generate keys and let them signed by our CA in the Avs IoT platform, download them. You can even, as I've showed you now, you can generate your own keys with your own CA. So then you are responsible, of course, for the key material of your certificate. So both options work. Bring your own keys or use the keys that we generate with our CA.
Thank you.
Thank you.
No problem.
Good.
2 questions. I love
it.
Second question, just to make you feel good. Excellent presentation. The devices are talking to the Greengrass over MQTT.
Yes.
Now, given that, is Defender capable of detecting traffic coming out of the devices on other protocols?
Yeah, so for the moment, I've put it on the Greengrass device, and it connected. So if the Greengrass device, for example, is a home gateway, it will also not only monitor this one. Now, you could also integrate, we have a device defender Python SDK, for example. You could also instrument your Greengrass devices to send also events from the Greengrass device to Avs Device Defender. In this case, you could monitor the different devices and the Greengrass core. We just have to integrate the Greengrass Device Defender SDK into your code to instrument it. Okay.
Can we go for 3? He flew all the way here from Germany. You may as well ask him another question. All right. Yes? Oh, here we go. I like it. This is my job, just to pull the questions.
Now, can we get your just-in-time registration script?
Sorry?
Your just-in-time registration script?
Yeah.
Can they get an example of it?
Yeah, I can. Yeah, we have a GitHub repository where I can share with you. Just come to the stage. I will show you.
And if you, on the security side, one thing we didn't mention during the session, there's also now a quick start for cameras. So if you, on the security side, in addition, we did a lot of audio example. On the video side, you can actually, it's live now. There's a quick start for Kinesis video enabled cameras, straight connected AWS IoT as devices, and then with the similar machine learning wrap, but it's a whole CloudFormation template as a quick start. So if you have one of those enabled cameras, you actually, a lot of our manual effort, which we had in the demo, is enabled with a CloudFormation template. All right, with that, we're winding down to our last couple of seconds. Thanks everybody for the questions, we really appreciate it.